Hello mate and welcome back to Let's Code Season 6. In this episode we're going to look at creating room prefabs that will enable us to make our map a little bit better. It means we can have rooms of different size and we can actually put items in specific locations in those rooms if we want to. So as you can imagine, we need to create a new file which we're going to put our new prefab class into. So we'll do that. You can call it whatever you want to, as long as it ends with .rpy, then Ren'Py will read it. And then as you can see, I've gone with init15 Python, and then we declare our class called prefab. It doesn't inherit from anything else. And then we've got our constructor, which takes the name, room type, room size, items, and item position properties. This is essentially all of the items that we need. We need a name for our room. The room type is going to be very important moving forwards. The size of the room, its X and Y size. Items, which we will sort out later on, and then the positions of those items as well. And as you can see in the constructor, we just take those properties from the arguments provided and actually put them into the properties of the class. So self_name equals name, and so on. And then we have our standard getters. We have get name, get size, get type, get items, and get item positions, which just return the values or the fields of the class, as we've done for pretty much every other class that we've created so far. So this stuff so far is pretty simple. Now we're looking at the XML file itself, and this is where we're going to be adding our prefabs. And an XML file, for those of you who don't know, is just a markup file that allows us to store data in a readable way. So as you can see, we've got data enclosed in around everything else. And then we've actually declared a prefab there that's called empty room with type empty, size 20 by 15. And then we have got an item there, but the item's name is none and its position is 0, 0. So this is going to be the file that we use to store our room prefabs into, and we'll come back and look at how they're going to look in a little while. But the next thing we need to do is add some code beneath our class. Now this is going to be inside the init15 Python block, but not within the class. So make sure that you've tabbed it correctly so that it is declared after the class, but not in the class. And then we're going to create an empty list called prefabs, just using prefabs equals square brackets. And then we're going to define a function called parse XML, and we're going to take a file name as its only property, or its only argument, I should say. Then what we're going to do is we're going to import the XML parsing module known as elements tree. So import xml.etree.elementsTree as et, and we're just saying as et just to mean that we haven't got to keep typing xml.etree.elementsTree every time we want to reference it. And then we're going to say the tree itself is going to be the element tree or et.parse, and then the file name that we've provided. So this loads the XML file into memory. Then we're going to say prefab equals, or prefab sort equals tree find all prefabs. So what this is essentially going to do is going to create a dictionary or a list. The one I'm trying to explain this in a simple way as possible. So it'll create a list of all of the prefabs that we've defined in our XML. And then within each one of those prefabs, we'll have all of the properties available, which you can see in the next bit where we loop through the prefab tree. So we've created a tree of prefabs, and now we're going to loop through it. And we're going to say for each prefab in our list of prefabs, we're going to create another temporary variable called pname, and we're going to say pname is equal to prefab.find, and then name.text. That's referring to the properties that we've defined within the XML file. The same thing for type. Now, X and Y need to be integers, so we need to cast our text into integers, which we've done here. So p size x equals int prefab find size x dot text, and same for y. And then we create our size tuple by combining those two integers together using brackets. So p size is equal to p size x and p size y. And then we have an item list is going to be basically, again, the same process that we did to get this list of prefabs. We're now going to look within this prefab and create a list of all of the items within. And then we're going to create an empty list of items and an empty list of item positions. And then we're going to loop through the list of items, and we're going to take the item name, the item's X and Y positions, exactly the same as we did for the prefab. and we're going to turn the item position in 2 coordinates that we got into a tuple, same as we did before, and then we're going to append that to the item positions list. Then we're going to prefabs.append, so we're going to add our prefabs list, a prefab with p name, p type, p size, p items, and p item positions as the arguments. Then all we have to do is, once we've defined the function, we're going to call the function with the command at the bottom here, parse XML, and then we're going to input the file name of the file that we've created with the XML data within it. So in this case, it's contained within the game directory in the data folder called prefabs.xml. The reason we call the function after we define it is just because we want it to be nice and simple, and if we were to put all of this code in the loop, if we wanted to change anything inside this function, it just becomes a bit of a mess. So we declare the function and then we call it. It's just a little bit simpler and a little bit easier to read. And it also means that if we decide to write another function that we wanted to test, so if we wanted to use a JSON file instead of a XML file, we can keep this code in and just not call the function, do our JSON stuff, see if we can get the JSON stuff to work, and then if it doesn't, we've still got the parse XML function ready to go so that we can play around as much as we want. Now, in order for this all to work, we need to make some minor changes to our room class. So at the top of our game room, we have our constructor, and we're just going to change the code so that it now has self name, exits, and room prefab as the arguments. And then it's going to take the room prefab get type method as the type, and it's going to do the get size method as the size. And that's going to allow us to be able to use the prefabs to create the rooms a bit later on, or very shortly in fact, when we use the map class to actually create the rooms based on the map. And here we are inside the map class, and as you can see, we're back in the loop where we loop through our map file. This time we've referenced global prefabs at the very top, and the reason we have to do that is because there are 2 types of variable within Python. There's global and there's local. A local variable would be a variable that we create inside a function. It's only used while we're running that function, and then it gets tossed away after the function has been completed. And then there's the global variables, which are the variables that stay in memory the whole time when we create them outside of a method or class. That means that we can access them from everywhere. And if you remember, our prefabs variable was created outside of any function, so it's a global variable that we can access. It's a list that we've populated inside of our room class, or below the prefab class, I should say. So now we're going to access the data, and we're going to read the map file, and we'll talk about how the map file is going to be changed in a minute. So all we're doing is we're referencing the global prefabs, and then this loop doesn't change very much. We're just going to add this piece of data below temp data. We're now going to say temp prefab equals, and then this line looks for a prefab which has the same type as the type that we've declared within the map. So next prefab for prefab in prefabs, if prefab.getType is equal to temp data2. In other words, we're still reading the type in temp data2, but now we're looking for a prefab that has the same type as the type that we've declared inside the map, and then we're going to use that instead. Now we're going to say if temp prefab is equal to none. In other words, if we've not found a prefab which has the same type as any of the types in our prefab list, then we're going to use prefab 0 as our default. And then all we're going to do is we're going to change the bit where we create a room. So rather than having temp data 0, temp data 1, and temp data 2, which is what we had previously, we're now going to pass in temp data 0, which is the name of the room, temp data 1, which is the number of exits, and then the prefab is going to be passed to the room class, which, if you remember from the previous slide, is actually what that is now looking for when we create the room. So ultimately our XML file is going to be huge because we're going to have loads of different prefabs within it. But what we've got here is just a sample of 2. And as you can see, the very first prefab that we've created is just an empty room. We've given it the type empty _ 20 _ 15 as a simple shorthand for it's an empty room, and the size is 2015. As you can see in the size X and size Y properties, we've actually got 20 and 15 as our values. Nice and simple. And what you might notice is that this prefab doesn't have any items within it. Now, because of the way we've written our code, this is fine. All that will happen is it just won't try to add any items to the item list for this room. It'll work, it's fine, it'll do the job. Now, the next prefab called Elven Garden, and again we've given it a type called eGarden_11_11, and as you can see the size is 11 and 11. You don't have to use this shorthand for the type. You can use whatever you want as a type. It can be any string you want. You can type in supercalifragilisticexpialidocious if you want to, but personally I just like to have some kind of shorthand so that when I'm creating the map I'm actually able to identify what room it is that I'm actually adding to it. And as you can see, we've got an item here that is item none, 0, 0 there. This is just to show that you can add items to the list, and you can have as many items here as you want. You just add them one after the other inside the prefab and it will add them all. And as you can see, this is the map now, and as you can see, John's room is now empty_20_15. Dave's room is also an empty_20_15, and Jane's room is an Elven Garden 11 by 11. So her room's going to be much smaller than the previous two rooms, and none of the other functionality of the code has changed, so we can still traverse between the rooms using the exits. The exits and entrances to the room will still be in the center of each room, so we should be reasonably able to play through this without any issues. As you can see, here we are inside the map. So if we whip across to where we know that Jane's room is, and as you can see, this room is actually 11 by 11, and we can jump back in and you can see that the previous room is 20 by 15. And because we haven't actually added any items, we haven't added the code to it, that functionality is not kind of there yet, but that's what we're going to be working on in the next episode, is adding that functionality to get us to add items in the prefabs as well. And then we'll have a fully functioning map so that we can then focus on the other stuff that we need to do. Anyway, that's the end of that episode, guys. It was a quick one, but the code is all there. I hope you found it useful. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.